So I'm going to start off by asking, we have other members, as you can see here. So I'm going to ask Swasti to introduce the other members that are not here today.
Okay. As you can see here, in our multinational team, we have a total of 10 people. Alex, Makaisa, Elira Makaisa, Tywin, Timothy, Felix, Jacob, Barbara, Beatrice, me, Swasti, and Nicole.
Thank you. Going on to the next slide, I'm going to ask Barbara to explain this one. So,
Bárbara, esse é o seu slide, se você puder fazer a sua apresentação do seu slide e depois eu traduzo para o inglês.
Tá bom. Esse daqui é o nosso experimento de limitação de sementes, onde aqui está mostrando o nosso cubo, que todas as sementes que vão ser colocadas no cubo estarão aqui. Nosso experimento STEAM irá estudar os efeitos da radiação do espaço nas sementes e na germinação delas e no seu crescimento. Aqui a gente pode ver a largura do topo, que é de 3,791 centímetros, a altura que abre a tampa, que é de 1 centímetro, a largura da abertura da tampa, que é de 3,809 centímetros, a largura do meio da caixa, que é de 3,768 centímetros, e a total altura da caixa, que é de 3,9 centímetros. Aí, aqui também tem a largura da parte de baixo da caixa, que é de 3,730 centímetros, e a largura da tampa, que é de 3,809 centímetros.
Thank you, Barbara. So I'm going to translate to English what Barbara just said. So just an additional information. The main objective here is for us to define a science experiment that is going to be executed in space. So this is an agreement between basically the team that we have here and NASA. We're going to basically fly on their RB10 flight, which is an atmospheric balloon which will go to the edge of space. And then Barbara basically provided you the details on what are the requirements that they have for us to define a science experiment. And this is the cube. This is a plastic cube that is going to go into space. And as you can see, it's really not much big. It's basically a cube of about 1.5 inches in all sizes. So that's why we are limited. And Barbara provided all the details on each one of those measurements. And what we're going to do is to try to define an actual experiment that can fit this box. And Barbara just provided us the initial detail that this experiment that we're going to do is really to study the effects of radiation in space into seeds that we're going to send to space.
So yeah, thank you so much, Barbara, for explaining this one. And for the next slide, I'm asking Beatrice to explain more on this one. So Beatrice.
Vamos usar 400 sementes de 2 tipos de hortaliças, onde 200 irão para o espaço dentro de uma caixa de acrílico.
Então, I'm going to translate in spaces here. Beatrice just said that we're going to use 400 different 400 seeds, and they are separated into two different types of seeds. One is going to be radish, and the other one is going to be collards. And half of those seeds, 200 of them, are going to be sent to space in the NASA flight RB10. And the other half is going to stay in our house so that we can later compare the effects of radiation on the seeds. Beatriz?
E as outras 200 ficarão na terra firme.
And the other 200, as I said, will stay on Earth. They will stay inside the house on a controlled environment so that we can do the comparison. Beatriz?
Essas 200 sementes, 100 de rabanete e 100 de couve, ficarão no espaço dentro de um balão por 4 a 5 horas. Depois retornarão para a terra.
So these seeds that are going to go to space, those are 100 seeds of radish and then 100 seeds of collards. They are going to go into space on flight RB10 from NASA, and they're going to stay there. It's a balloon, so it will go and stay on the balloon, in the balloon for about 4 hours. And then we're going to study later on the effects of radiation in those seeds. Beatriz?
Assim, nosso grupo poderá testar as sementes que ficaram expostas por radiação e aquelas que ficaram na Terra.
So the main objective is for us to compare after the flight, when we receive the seeds back from NASA, we're going to compare the germination rate and the growth rate of those seeds between those seeds that went into space and the seeds that stayed here on Earth. Beatriz?
Com isso, podemos ver a evolução delas, como germinação, crescimento e produção e etc.
So the main objective is really to be able to study the germination rate. So we're going to basically see how many of those seeds will be able to germinate, and then the growth rates, and compare those with the ones that stayed on Earth. Beatriz?
Cada de nós irá receber 40 sementes para o experimento.
So there are 10 people in the team, 10 teammates. Each one of the teammates will receive 40 different seeds. The ones that went into space, the one that stayed here on Earth, and then each one of the 10 members will do that comparison, checking the germination rate and growth rate. Beatriz?
No.
Okay, I think that's all.
Já terminei.
Okay, that will
Thank
be
you.
all. Nicole.
Yeah, thank you so much, Beatrice, for the explanation. And so the next slide, I'm gonna ask Tywin to tell more about this one.
Okay, so this is my slide. So basically, we're going to have 10 seeds that were after the flight in October. We're going to be mailed back. NASA's gonna mail us the seeds, and then we're going to plant them at home at different containers. Then we're gonna check the growth rate and the germination rate. If their growth rate and germination rate is high, then that means they really do germinate. Then we will send our findings with our discoveries back to NASA. Thank you.
Thank you so much, Tywin. And I'm gonna explain this one, which we had two choices, but as you can see, we picked the scientific balloon. And so why we picked the scientific balloon? Well, because we were, as they said, we were focusing on the germination rate and the radiation. And so since the rocket only stays about 5 minutes in space, and the scientific balloon stays in 4 hours, we picked the scientific balloon so we can have more of those effects. For this one, this is going to show our timeline and what when are we gonna start our experiment? And so we already did the first start of the levels to show to the NASA. So it will be shipped in the NASA balloon in mid-August, and then it will be shipped back to us in September, and then in October we're gonna start doing the experiment. And so you can see more details in the link below. And I'll also show that on the next slide, which you can see the QR code explaining more details on our experiment working together. And so if anyone has any questions, you can ask any of us members for your questions. So does anyone have anything to ask?
I have one if anybody else is not going so far. The seeds that you have, are they all like directly, are some of the seeds like, what are the problems, the outside factors that you've considered that might mess up with your experiments?
So, the only thing is it's gonna be all controlled, so it will probably just be like small mess ups, like, but we're all gonna keep it like one of them inside our houses and one of them outside, which is the scientific balloon. And so that's why we did all of us members doing it, so we make sure that we all get a similar result.
So you don't think there's anything like any factor that's outside of the just general outlook? Like there's no problems that you can think of, right?
There's none of that I can think of right now, yes.
All right, thank you. Anybody else have a question? Anything in the YouTube chat? Any factor?
You may have mentioned this before, but I'm curious how you got your partnership with NASA.
So, they actually have a competition. So they have a competition called Cubes in Space. And so that's where we entered in. And so we're going through that process right now, that if we are able to get the approval of NASA, we'll be able to continue this experiment. And I was able to attend last year, so I'm going again with new members. And so, as I said, so we can have this experiment in different areas and be able to get results.
Thank you. I think you did mention that. I'm sorry.
I just want to quickly, if
Mhm.
no other questions, that I think this idea is like groundbreaking and amazing. Like, who would have thought of putting seeds in space and comparing them to the regular? Like, you don't. It's really cool that you think of radiation as a factor that can affect growth of a seed, and I just hope really good results come out.
Thank you so much, Sid. So does anyone else have any questions? Or you can ask any of the members.
Great presentation.
Yes, I think it's amazing. I can't wait to follow this, and see where everything lands. I think this is awesome.
Thank you so much.
Thank you for presenting. We appreciate it. I know it takes a lot of time to coordinate all of this with all of the different countries you're working with, and you've done a great job as usual, and so has the whole team. Everyone's done very well. Thank you very much.
Thank you, Miss Julie.
You're welcome. I'm sure we'll see you again. Are you on any more of this event?
I think there's 2 more on the projects.
Okay. And then tomorrow, just so you know, the student mashup is at 10 o'clock Eastern time, run by Ms. Amy Ashcraft, and it's on creativity. And then right afterwards, Gia Nagpal from India has a student panel discussion if anybody's interested in coming back. That's at 11 o'clock Eastern time. So we would appreciate anybody to participate in those, because I think they're both great opportunities for students from different parts of the world to express their opinions and their insights and their perspectives on things. And it's interesting how different they can be just because of the different places people live. So hopefully we'll see some of you there.
That sounds very interesting. I'll think of doing that. Thank
All
you
right.
so much for giving the opportunity, telling the
Yeah.
opportunity.
Sure. All right. Well, thank you guys. And we will work on moving the next group up.
Thank you so much. Bye.
Sure. Bye.